Hello everyone, and welcome to this tutorial on dynamic arrays. Dynamic arrays are fundamental data structures in computer science that every programmer should understand. Unlike regular arrays with fixed sizes, dynamic arrays can grow and shrink automatically as you add or remove elements. In this video, we will understand how memory allocation works and learn about resizing operations that happen behind the scenes. This tutorial is designed to be perfect for beginners in programming, so even if you're just starting your coding journey, you'll find this easy to follow. So let's dive in and discover how dynamic arrays make your programs more flexible and efficient. Before we dive into dynamic arrays, let's quickly review static arrays to understand the difference. A static array is an array with a fixed size that must be declared at creation time. Once you create a static array, its size cannot be changed after declaration. Static arrays are stored in continuous memory locations, which makes them fast for accessing elements. Let's look at an example. If we declare an integer array called numbers with size 5 and initialize it with values 10, 20, 30, 40, and 50, this means we can store exactly 5 numbers in this array. Here's the important limitation. Once this array is created, you cannot add a sixth element. If you need to store more data, you would have to create a completely new array. This fixed size limitation is exactly why we need dynamic arrays, which we'll explore next. Now let's understand the problem with static arrays that makes them difficult to use in real applications. The first major issue is that you must know the exact size in advance before creating the array. This creates two problems. If you allocate too much memory, you end up wasting memory space that could be used elsewhere. But if you allocate too little memory, you run out of space and cannot store all the data you need. Let's look at a real-world scenario to understand this better. Imagine you are building a contact list application. How many contacts will your users add? Some users might add only 10 contacts, while others might add 500 or even 1,000 contacts. With static arrays, you would have to guess this number in advance, which is nearly impossible. This is the key limitation. Static arrays cannot adapt to changing data needs. This is exactly why dynamic arrays were created, and we'll see how they solve this problem next. So, what exactly are dynamic arrays? Simply put, dynamic arrays are arrays that can automatically resize themselves as needed. Let me explain how they work. Dynamic arrays start with an initial capacity, which is a small amount of memory allocated at the beginning. When you add more elements and run out of space, the dynamic array grows automatically to accommodate the new data. Similarly, when you remove elements and have unused space, the array can shrink automatically to save memory. The best part is that dynamic arrays handle all the memory allocation and resizing behind the scenes, so you as a programmer don't need to manage this yourself. This means you don't need to worry about the size of your array anymore. The dynamic array takes care of everything automatically, making your code simpler and more flexible. Let's see exactly how this resizing process works in memory. Now let's see how dynamic arrays work in computer memory with a real example. Here we have a dynamic array in its initial state. The array starts with an initial capacity of 4 elements, meaning it has space to store up to 4 values. However, the current size is only 2, which means we are currently storing only 2 elements. Let's look at the memory layout. Each element in the array is stored at a specific memory address. At address 1000, we have the value 10. At address 1004, we have the value 20. Notice that addresses 1008 and 1012 are empty because we haven't used that space yet. The important thing to understand is that the array has reserved space for 4 elements, even though we're only using 2 right now. This extra space allows the array to accommodate new elements without needing to resize immediately. Next, we'll see what happens when we add more elements to this array. Now, let's see what happens after we add more elements to our dynamic array. We have added 2 more elements, the value 30 at address 1008 and the value 40 at address 1012. Notice that the cells containing these new values are highlighted in light yellow to show that they were just added. The current size is now 4, which means all 4 spaces in our array are being used. Our array is now full, with no empty spaces remaining. But here's an interesting question. What happens if we try to add a fifth element? We don't have any more space in our current memory location. This is where the magic of dynamic arrays comes in. In the next example, we'll see how the dynamic array automatically handles this situation by resizing itself to make room for more elements. This automatic resizing is what makes dynamic arrays so powerful and flexible. Now let's see the magic of dynamic array resizing in action. At the top, you can see the old array with capacity 4, which is now full. When we try to add a fifth element with value 50, the dynamic array automatically creates a new larger array. The new array has double the capacity, which is 8 elements, and it's located at a completely different memory address, starting at 2000. Here's what happens during resizing. First, all the existing elements are copied from the old array to the new array. You can see values 10, 20, 30, and 40 are now in the new memory locations, highlighted in light yellow to show they were copied. Then, the new element 50 is added successfully at address 2016, shown in light green. The new array now has room for 3 more elements before needing to resize again. After this copying process is complete, the old memory at addresses 1000 through 1012 is freed and returned to the system. This automatic resizing process is what makes dynamic arrays so flexible and powerful for handling growing data. Let's summarize the key benefits of dynamic arrays and understand when to use them. First, dynamic arrays provide flexible size. They grow and shrink automatically based on your needs, so you never have to worry about running out of space. Second, there's no need to predict the size in advance. You can start with a small array and it will expand as needed when you add more data. Third, dynamic arrays provide efficient memory usage. They only use the memory you actually need, avoiding waste. Fourth, they offer automatic management. All the resizing and memory allocation happens behind the scenes, so you can focus on writing your program logic. So when should you use dynamic arrays? Use them when you don't know the data size at the start of your program, or when your data changes frequently with additions and deletions. Dynamic arrays are perfect for building real-world applications like contact lists, shopping carts, or any situation where data grows over time. Remember, dynamic arrays make programming easier and more flexible by handling all the complexity of memory management for you. Thank you so much for watching this tutorial. I hope you found this lesson helpful and easy to understand. If you enjoyed this video, please hit the like button. It really helps the channel grow. Don't forget to subscribe to the channel for more beginner-friendly programming tutorials and helpful tips. Feel free to comment your questions or thoughts below. I love hearing from you and I try to respond to every comment. And don't forget to hit the bell icon so you get notified whenever I upload new videos. See you in the next lesson.